So I wanted to review some rules of equations because in this class we're going to take our equation solving skills up to the next level. We'll be doing quadratics, polynomials, other equations. So we got to make sure we can do the basic ones before we can move on. And there were some things that I just noticed you were doing that, that we needed to discuss. So we're going to do the odd ones together, and then it is going to be your job for the rest of class to work on the evens. Okay, so let's take a look at problem number 1. Anytime you're trying to solve an equation, please just simplify one side as much as possible. Simplify the sides before you start moving around is a good tactic. So 4n minus 2n is 2n. And then because that 2 and that n are touching, that means multiplication. So to divide, we'll get rid of the 2 that's in front. And we get a value of 2. So that should be pretty straightforward. Now, at any time to check an equation, especially one that's just like a one variable equation to the first power, perfect little nice little equation like this, feel free to, you can plug it in. If you plugged a 2 into the original, you would get 8 minus 4 equals 4. So it should make a correct statement. So checking them should be an easy thing. You can just do sometimes in your head. Now on a quick, yeah. Okay, so just divide both sides by 2. And then you get n is equal to 2 after you've combined them. Are we good now for number 1? Okay. Now let's look at number 3. Now on 3, it's the opposite side, but it's still the same technique. This side's done, so this side we need to combine or do whatever. I notice that this term and this term are like terms. Now, we know that because they have the same variable with the same power on it. And it's really like 1 of those minus 5 of those is negative 4 of those. Now, it's okay to write it as negative 4x plus 3 like I did. That's okay. You could have also done 3 minus 4x, written it like that. They're exactly identical. It doesn't matter. As long as you take the sign with it, you're good to go. Okay. So now you are going to need to isolate this term. Now, the 4 stuck on it, so we don't want to do that first. We do need to move that 3 over with the other one. So we're going to subtract 3 from both sides. And we get that negative 4x is equal to 0. Now, 0 is a legitimate answer. We can't divide by 0, but we can multiply things by 0. We can divide other things into 0. So where it sits now, some people think, yeah, oh, I did something wrong. You didn't. It's good. Because if you divide 0 by anything, we still are going to get 0. So you can't divide by 0, but you can have 0 in your numerator without a problem. And so our answer is 0. And if you put 0 up into the top, here and here, you get 0 plus 3 minus 0 is 3, which is what we should check. So you can check these very nicely, just shove them into the original. Do we have any questions about how I did number 3? Okay, let's move on to 5. Same kind of thing that I noticed in number 3, that our left side was just a number and our right side needed fixed a little. I noticed that same thing is happening with number 5. So these two terms right here are like terms. So we can put those together. So anytime we can simplify a little bit, that's always a good idea. So negative 2k's and negative 3k's. Remember, if they're the same sign, add the numbers and keep the sign. If they're different signs, we're going to subtract and keep the sign of the largest value. Okay. And then again, we need to isolate this. Now that negative stuck on the 5, so just look at what's the 3. Now the 3 itself is positive, so that's why we have to subtract 3 to get rid of it. So just think about what's in front of the thing you're trying to move, and that's where you do the opposite of that. So that's why we needed that minus 3. So we get negative 15 equals negative 5. k. And then anytime you have a coefficient or anything stuck on a variable, that just means you're multiplying, the opposite of which is division. So we've got to divide that negative off. To divide two negatives, a negative divided by a negative is always a positive. And then now, because what happened over here, the negatives canceled, the 5s canceled, we're only left with the k is exactly what we wanted. So k is equal to 3. If we put 3 back into the original version, we should get negative 12. If we put 3 here. We get 3 minus 6 minus 9. 3 minus 15 is the negative 12 we were searching for. So plugging that back into the original, like if you were taking a test, that's a really good strategy to just check your work real quickly. Plug it back into the original. Does it make it a true statement? Are we good with 5? Okay, let's move on to 7. Now 7 is the first one where we have the distributive property kind of showing itself. There are 2 ways to solve this problem. I'm going to show you both. I do not prefer one way or the other. Negative 3 is multiplying by this, so the opposite of multiplication is division. So we are technically, in an equation you have a lot more power than if it was just an expression of some sort. So to me, if I were doing this problem, since 6 is nicely divisible by 3, I would divide both sides by negative 3. Let me make that look nicer. So if I were doing it, I would divide off the negative 3. And then 6 divided by negative 3 is negative 2. And then the parentheses drop down without the parentheses. It doesn't matter if you write the parentheses, but the 3's cancel, the negatives cancel, so we're left with that quantity. And since it's all by itself, you don't need the parentheses anymore. And then we just subtract off 2. So we get that x is equal to negative 4. So that's a legitimate way to do that problem. Okay. Now I would like you to write down a second way. So could you please rewrite the equation again on your paper? Rewrite the equation again on your paper. And I want to talk about an alternative way to do this problem. Now, if you looked at it and said, I need to use the distributive property on the right side, that's okay. You would distribute the negative to both pieces. When you do that, you get negative 3x minus 6. And now it just becomes very similar to some of the problems we solved earlier. Let's add 6 to both sides because we want to isolate that negative 3x. We get 12 equals negative 3x. Now that negative 3x is alone, now and only now do we divide off the negative 3. Do you see how here we divided off the negative 3 first? Here we eventually have to divide by negative 3 anyway. But our answer is still negative 4. Okay? So it is up to you which technique you decided to go with. You could divide off the negative 3 first. If it's not divisible, I don't do that. Like if we had the number 7 on the other side, which isn't divisible nicely by 3, I wouldn't do that. I'd use the distributive property. But if it's divisible, why not get rid of it? So, you know, both of our methods get us to the same place. And I always want you to know that, you know, if you get the same answer I do, but you take a slightly different path to get there, that's okay. Yeah, it doesn't matter. Are we good with the methods we see for number 7 and how those work? Make sense? Okay, let's take a look at number 9. So when I see this, I just ask myself, can I easily divide by 6 on both sides? If I can, that's the technique I usually prefer. So since both sides are so nicely divisible by 6, I can avoid the distributive property by just dividing off the 6. You're allowed to do that. The rule of equality says that as long as you do the same multiplication or division addition or subtraction on either side, it doesn't affect your outcome. It still is going to work. So because 24 is so nicely divisible by 6, why not? So we get 4 equals the quantity that was inside, negative x minus 3. So I do prefer that method. Again, distributing isn't wrong. We still have to isolate that x term, so we are going to add 3 to both sides. We get 7 equals negative x. Now that's what negative x is equal to. How do we get rid of that negative in order for us to find out what positive x is equal to? How do we get rid of that negative? What do you think? What math are we going to do to get rid of the negative? Divide. What are we going to divide by? Yeah, just divide both sides by that negative. You're technically using negative 1. If you like to put a little 1 there to see that that's really negative 1 times x, if that visual helps you, put the 1 there. And then I will see that you're going to divide off that value of negative 1. And so 7 divided by negative 1 is negative 7. And then you can see that the negatives cancel nicely, and you're just left with an x. Good? 9 good? Let's take a look at 11. Now for our first, this is our first equation that has a variable on both sides. We still want to use the technique. Let's go ahead and simplify both sides as much as possible. If you decide to divide by negative 3, each one of these would have to be divisible by negative 3. Is 14 divisible by negative 3? No. 1 isn't. I mean, it's going to give you a fraction for both of them. Don't do it unless it benefits you. That's what's great about an equation. You have a little bit of control, okay? Instead, we are forced, I think, because the negative 3 doesn't go into the other side nicely, we got to use the distributive property as our first step. When we do that, we get negative 3. Now, be careful, because it's negative 3 times 1 and negative 3 times positive 6r, which would be negative 18r. And then there's nothing we can do to either side. Now we start moving around. So it doesn't matter which way you go. I do tend to think about where can I make things positives. That's usually helpful. It doesn't matter. Again, there's lots of ways to do an equation. But I am going to add 18r to both sides. That's going to put the r on the right, which means I need to move the 14. Let's change that so you can see. I'm going to need to move the 14 to the left. Okay. So I'm going to add 18 r's to the right, and I'm going to subtract 14, so it'll move it over to the left. Okay. So you'll notice, hopefully, that those cancel. That's great. That's what we wanted. And those cancel. That's what we wanted. And so we get that 17r equals negative 17. 17r equals negative 17. So now, the 17 is a coefficient, so we can just divide it off. So let's divide off the 17. A negative divided by a positive is a negative. 17 divided by 17 is 1. Now, even though this equation is a little more complicated, the technique of plugging it back in is okay. If you plug negative 1 into this side, you get 15. If you plug negative 1 into this side, you also get 15. So you can check it very quickly. It does work. Everything's good. Everybody good with 11? Reminding you of the rules of equations a little bit. That's the goal. Okay, 13. Now 13, again, initially treat each side as its own simplification problem. For 13, the right side is simplified as far as we can go. So we really just have to focus on the left side. Anybody notice a property that we have to use on the left side kind of as our first step? What's a property we can use on the left side? The distributive property. Let's take that 2 and distribute. Okay. When we do, we get negative 4k plus 10k minus 12. And that right side, we're not going to touch for a while because the left side still has some simplification to go. If it has more than 2 terms for these type of equations, there's still something we can do. On this left side, what are the terms that we can combine? What? Yeah, yeah, you got it. These ones here are like terms. They're different signs, so subtract. 10 minus 4 is 6. So you're right, we got 6k minus 12. And now if you notice, both sides are simplified as much as possible. Now, start moving things around. Now, again, you might choose to move something to the left, and I might choose to move something to the right. Nothing wrong. I'm just going to show you what occurs to my lovely little brain. So we're going to add 3 k's to both sides. We'll get that over there on the left. So now my k's are to the left. So then let's move this 12 to the right. Now you can do that in 2 separate steps. When I can save a little time and space, I do tend to try to be a little efficient. On the left side, the 12s cancel. On the right side, the k's cancel. And so we get that 9k equals 27, negative 27. And that's nice. Most of these are going to come out to be fairly decent numbers. I think maybe a few on the bottom might be fractions, but most of them could turn out pretty nice. And then what do we do to get rid of that 9? Divide. So we're going to divide by 9. And so we get that k is negative 3. Again, you could plug it back into the original equation. You should get the same thing on both sides. We do get negative 48 equals negative 48, if you're wondering. If you plug it back, or I'm sorry, no, you get negative 30 equals negative 30 if you plug it back in. So that is 13. Do we have any questions on how we went about doing that one? Quite a few steps, but just take it a step at a time. Simplify both sides as much as you can before you start moving things around. Okay. 15, you'll notice that we have just lots of stuff. And we did those simplification problems first because you see how much they show up in an equation or can show up in an equation. So we're going to simplify the left side as much as we can. We're going to simplify the right side as much as we can. Treat them as 2 separate problems. Okay. So let's focus on the left side of number 15. Okay, so let's focus on the left side of number 15. So we can combine the p's. 10 p's take away p is 9 p's. We can combine the just numerical things. 9 minus 11 is negative 2. So the left side in 15 is a lot nicer than the right side because of the fact that we don't have to distribute or do anything funky. So we've got it down to 2 terms. So we're done with the left side at the moment. Can't go further. You can't do anything else. Okay, everybody good with the left side of 15? Makes sense? Okay. Now let's jump to the right side, which I've highlighted here in pink. So this looks very much like a problem from the quiz, I believe. We're going to distribute the negative 2. Don't forget the negative goes with the 3. We're going to distribute the negative 3. So we're going to have 4 pieces that we have to simplify. Okay. Now first let's distribute the negative 2. When we distribute the negative 2, we get negative 4p minus 8. Remember that negative goes with it. It jumps into the parenthesis with it for both pieces. The negative 3, the negative jumps with the 3. And so we get negative 6p plus 6. But our right side still has things that can happen. So let's put our p's together. Let's put our 8s, their numbers together. So we have a total of negative 10 p's. And then negative 8 plus 6 is negative 2. Now, only once you have gotten to the point where you have simplified both sides as much as possible do you want to try to start moving things around. Okay. And again, what side to move to. One's just as better as the other. I'm going to add 2 to both sides. And I'm going to add 10p. Okay. And so we get 19p equals 0. Now this is another one that 0 shows up and you think, gosh, I must have did something wrong. You didn't. You're good. Just if you divide by the 19. You can't divide by 0, but divided by the 19 is okay. You get that p equals 0. Okay. So I'm going to give you a minute to work out 17 and 19 on your own. That's a good practice. I am going to show you the answers up here, so then you can check your 17 and 19 to make sure you're on the right track, and then it is your job for the remainder of class to work on the evens, okay? If you don't get it done, it becomes homework and you need to take a picture and it's submitted in Google Classroom. If you get it done in class, take a picture, put it in Google Classroom. So I'll do 17 and 19 up here now, so you have it to look at. But do it on your own before you look up, unless you're very confused and you need more help. And you can check that you're getting the right answer. And then try the critical thinking problem once you finish up your evens. I started 19 and then failed miserably and needed to start over. I just made a weird mistake. So the answers are up on the board for 17 and 19. So check your work. And then if you have any questions, let me know. And then evens as you go. If you have any questions, let me know. I'll post the answers up on the board eventually here. So there you go.